Okay, today I'm going to talk about chapters 4, 5, 6, and 7. First, we're going to look at delegates. So, what is a delegate? Basically, a delegate can be used to represent a method. It's like a class because it's also a type, but delegates are used to reference a method. So, instead of explicitly calling a method when you need it, you can use a delegate in its place. And then you just type in the number into the code for the value you need. And this is what it's going to look like whenever you declare a delegate. Here you can see I have two integers, and there's two ways to instantiate a delegate, but for right now I'm just showing this example. And once that delegate is assigned a method, that's when you can use it. And essentially the delegate is going to represent the method and work like the method it represents. And with the multicast delegates, so far we've learned that delegates can represent just one method at a time, but they can actually represent multiple methods at the same time. You just need to use the plus equal operator or the minus equal operator to remove delegates from the list. Next, we're going to look at events. So, what is an event? An event is basically a notification sent from one object to another object. And events allow a class or object to tell other classes or objects when something occurs in the former class. So, for example, if you clicked a button on a Windows form, you could have it pop up with a window displaying a message, but that message wouldn't know when to display without the event handler telling it after the button's clicked. That's when it needs to display the message. And when declaring an event, so an event is declared in the same class where the event can be sent. An event, say, when an event is, when an object on the form is changed, it could raise an event. Next, we look at subscribe/unsubscribe. So, when adding a method to an event, you have to subscribe it. And in order for the program to even do anything, you need a method. But to subscribe that method, you have to use the plus or equals or the minus equals if you want to remove it. But you use the plus equals to add the event. And it's like adding a method to a delegate. And next we can dive into chapter 5 and look at an anonymous method. So what is an anonymous method? It's basically a method without a name, just the method body. And the purpose of this anonymous method is that when an instance of a delegate is created, an anonymous method can be assigned to it immediately. And with the lambda expression, it does the exact same thing. It's just simpler. There's less code. You just use the equals and greater than sign. Next, we can look at LINQ. Stands for Language Integrated Query. So what is LINQ? Well, LINQ was an attempt to have one query language for all. Essentially, it provides a looser link between the application and the data, allowing for more flexible programming. And the most common way to write LINQ is query syntax, which is the most popular among developers. It's the one that's closer to English and more readable. And next we can look at the operators with LINQ. So the first operator is where. It's used for filtering. So it can be used to filter out data rows in a data source. That means that meets certain conditions. For example, you could filter out everyone with a birth date after 2001. And next we have the order by. So this is used for sorting results. For example, you could sort by ascending or descending order if it was like customer ID or GPA. And then lastly, we have the group by operator, and this is used for grouping. So, for example, we could group suppliers by country, or you could group students by gender. And then lastly, we have the join. So this operator is used to create an association between two sets of data on one or more common key fields. So they have to have at least something in common to be joined. Like they both could contain supplier ID or something like that. And then next we look at the extension methods. So an extension method is just a method that you add to a type without using the source code of that class. It can be convenient when you don't have access to the class's source code. The example we did in class was the shout. So we created our own method that changed all of the string to uppercase and added some exclamation marks. And then we just added on the shout method to whatever the user input was, and then it would change the user input based on our method. Next, we look at culture basics. So culture is the leadership, belief, value, and knowledge of a group of people that influence the behavior and actions of the group or its environment. So with agile culture, people do whatever they feel is best for the completion of the software. And these are often identified as like self-organizing teams or autonomous teams. And then we have four main values for agile culture. And the first one is individuals and interactions. The second one is working software. The third one is customer collaboration. And the fourth is responding to change. We also have four results of the brainstorming phase. So first one we have is transparent. Second one is innovation. Third one is customer centric. The fourth one is collaboration. And next we have the organizational culture of Agile. So organizational culture can impact the adoption of Agile software development methodology. And a lot of businesses have organizational policies, and these are the result of organizational culture formed over the time. But to improve the organization, um, it's commonly believed that management should move towards more collaboration. And next, we're going to look at the keys to success. So what we're going to go over is management, organizational issues, people's issues, process-related issues, and technological issues. So it's a common belief that organizational culture affects the social structure of the organization, which in turn influences the individual's behavior. So organizations need to encourage more teamwork and should center or adjust their reward systems towards team performance and not individual performance. And second, we have people's issues. So members need to fit together for Agile. If a member who won't merge into the Agile culture is assigned to a team, it's recommended that the member works outside the team for some basic coding. And third is the process-related issues. So organizations should embrace change-oriented processes instead of compliance-driven processes. So the Agile culture requires the change from process-centric to people-centric processes. And lastly is the technological issues. So with always using new technology, everyone needs to be on the same version. Other issues can arise when testing and refactoring. So this is why test-driven development is so important. So you're not testing along the way, then you could just be piling up more and more issues. And next, we just go over inserting data into a database. So you just need to connect the database to the solution, the Windows form, and then you can use the insert into statement to put new values into the table on a database. And you just have to know the table name and then what columns and rows that you want to enter your data to. And lastly, we look at technical debt. So technical debt is defined as sub-optimized programming that will result in higher maintenance and more difficult reuse later down the line. So this can happen whenever there's a strict deadline and people are running behind. You can write code a lot faster if it's not done properly, and then this increases the speed that the project's done, but in result can have consequences later down the line. So there's two dimensions to technical debt. We have evolution and quality. So with evolution, technical debt isn't always caused by just rushing a project, but it can occur when programming languages or structure becomes outdated. And this can make it difficult to reuse if code was written a long time ago and a structure version not commonly used now. Then second, we just have the quality dimension. So this occurs when just the code quality is low. Usually the program will still run, but it's known to cause major maintenance issues later on. Just because the program runs doesn't mean it's easy to update, fix, or just do any maintenance on it. Next, we look at the causes of technical debt. So the number one cause is inadequate architecture. The second cause is inadequate testing. Third is code complexity. And or no, sorry. Second is inadequate documentation. Third is inadequate structure. Fourth is inadequate testing. Fifth is code complexity. And six is violation of best practices and style guides. Then lastly, we can go over some strategies for tackling technical debt. The first strategy is always to make it visible and explicit to the whole team. This is a good learning tool for everyone to show everyone what is right and wrong. And the second strategy is to manage the expectations of the managers. So technical debt is often the result of the balance between software quality and business reality. You can't always avoid technical debt if there is a strict deadline. Sometimes it's not worth it to just have perfect software and have it roll out very, very late. Third is conduct a risk analysis. So, like I just said, not all technical debt is bad. A piece of software that can beat competitors' time to market and generate more business value may be fine if the debt is handled in a timely manner. And then fourth is to do nothing. So this can happen if the technical debt is just too costly to remove, or if it was just caused by business reality and there's just no need to fix it. And that is it. I think we covered everything. Thank you.